Alright, so I want to talk about functions, and then maybe we can use that prep problem A2 as like a motivating example. We can try that at the end or something, okay? So, do people know what a function is? So maybe this game could be give definitions, okay? Definitions, it's one of those things, it could be considered really easy. Sometimes, you expect it to be given to you already. Or on the other end of the spectrum, it can be really difficult. Um, it's kind of the point at which something becomes mathematics, right? Like geometry wasn't mathematics until you could make a definition. All right, so how do we define a function? So let's start with function. Can someone give me a definition of a function? What is a function? Anyone? A function is defined as a relation between a set of inputs having one output each. Hmm. Defined as a relation between a set of inputs having one output each. Yeah, I mean, yeah, like Google is not really that helpful in this case, I guess. Anyone else want to give it a try? See, the fact that you had to say that's what Google said meant you didn't really understand what it was saying, right? So there's the notion of input, yeah, but it changes. This doesn't make sense. No. So it doesn't have to be an equation, but you do input something and you output something, yeah. Yeah, so if you say is an equation, then hmm, then you're saying like sort of there's more equations than functions, you know? And equations usually with like algebra and stuff. So functions might not actually come in that form. Okay, so maybe I'll give a weird definition then. So a function consists um, of two sets. Okay, let's call it x and y. And a relationship f between the sets that satisfy um, the following conditions. And so every everything in one of the sets, x and x, is assigned some y in y. Okay. called f of x. Does everyone understand this first condition? So every x in x is assigned some y and y, and this is a thing which is assigned is called f of x. And I guess one of the key things that is hard to express, but once you have the x, the y that you get only depends on that x. So if you reassign if you look at what x is assigned to, it's going to be the same y no matter like how you look at it. Okay, it can't be like one y in one instance and another y in another instance. Okay. So another way of saying that is like every input has to have an output, and yeah, that's it really if we're going to express that properly. So maybe so I guess I already have a question. Does everything in capital the set y have to be um assigned to something in x or not? Okay, so we call x the domain and y the codomain. Set of inputs for a machine or for process. Okay, do you have any questions about this definition? Okay, so if you understand this, maybe this is a question I can ask you. How many functions are there that go from the set 1, 2, 3 to the set AB? Hmm. How many functions are there? Do people understand the question? Okay, so I defined something called a function between two sets, and then I gave you two sets, and I want you to tell me all the things which satisfy this definition of a function. Maybe I'll write it a bit more than two functions How about that? Okay, I kind of suspect one of the reasons you don't really understand what I'm saying is because you didn't listen to the thing the first time. So do you still not understand the question or what? So can you give me an example of a function whose domain is 1 to 3 and whose codomain is a and b? Hmm. So I can define a function like f of 1 equals a, f of 2 equals b, f of 3 equals a. You understand? So I've assigned exactly one thing to a, 1, 2, and 3. Yeah? I've assigned a to 1, b to 2, and a to 3. So that shows that there's at least one function between those two sets. You know? How many functions are possible between these two sets? Four. I don't think so. So I need basically everyone in this class to come up with an example of a function. Okay, so I came up with one. So maybe people can just come up with an example of a function. Okay. I feel like if you're guessing, I don't know why you're guessing. Like you should just do the problem. Yeah. So come up with an example of a function, everyone. Yeah. So I mean, this exercise is to help you understand the definition of a function. So you're given two sets, and you basically, for a function to be defined, you need to assign everything in the first set something in the second set. Okay? Okay, you're not really listening to what I'm saying, are you? No, Nathan, are you retarded? I'm talking about these two sets. No, you need to do one for every 1, 2, and 3. You can't just say f of 3. You need everything in the first set to be assigned. Yeah, okay, Alon has come up with a function. Yeah, so the whole point of this example, actually, in practice, is just to show you that when you were listening, you didn't actually understand what the definition of a function was, okay? But that problem wasn't even a thing until you saw this question, okay? F of 1 equals A, f of 2 equals A, f of 3 equals B, okay? So that's another example of a function. Okay, Alon is supplying more than his share. Maybe Alon can think about what the actual answer is to the question. Nathan saying B. I don't know why you're using little b and capital B. BBA. I see. Okay, we need the other people in the class to give an example, okay? Is this too easy for Rihanna? Because I do hope to get further than this. Oh, by the way, this is in your like year. This is in your HSC syllabus as well. Like, this is it should start in year 10 in your in high school, but obviously the concept itself is fundamental. All right, Slava BAA. Welcome to team having found a function. BAA. Nathan's trying to come up with another example. So we really need the Mins, we need the Priyankas, and we need the yeah, I don't know if I require Rihanna to come up with one, but hopefully she can. Yeah, so whether or not that works, you have to think about whether it satisfies the definition that we set. Yeah, so okay, so if you set them all to equal to A, if you set them all equal to B, these are called constant functions, okay? Because they stay the same value, okay? So the requirement just said that everything had to be assigned to something. It didn't have to say they have to be assigned to different things, right? Okay, so okay, that's what about the other min? It gets harder the longer you wait because well, all the examples get taken. There might not even be any left. Yeah, see, it's hard to think of one that hasn't been done yet. Yeah, I mean, we could have been a bit more systematic about this, but we've had ABA, AAB, BBA, BAA, AAA, BBB. What haven't we done? BAB. Okay, BAB. Okay, well, so Lon, how many should there be in total? Yeah, so it should be 8, right? There are 2 possible assignments for each of 1, 2, 3, and these are independent of each other. Therefore, there are 2 cubed. Possibilities in total. Yeah, ABB has not been done here. Okay, and that's all of them then, yeah? Yeah. So sometimes we see the notation. So this is maybe not in school or even Math Olympiad, but you see x to the power of y. X to the power of y. So y to the power of x to denote the functions from the set of functions. And I guess that's maybe one way you can define 0 to the power of 0. It's like the empty set to the number of things, the number of functions from the empty set to itself. Okay. So hopefully that caught you all up on what a function is. So you don't usually see these kind of discrete functions in school as much. You do more like continuous functions. But basically any kind of property you can imagine has like a name, okay? And so the goal of this exercise is to define those names, or like assign the names to the property, okay? So, um, okay, so can someone possibly so there's three things we can do here. Okay, I give you the name, and you tell me what the name suggests it means, and then give me like a formal definition. Or I tell you like a property, and then you might be able to try to come up with a name. Okay. Okay, so maybe I should start with something easy. So a function is constant if what? Let's see. Let X will be a subset of the real numbers, and for most purposes we can take y equals r. Okay, so the brief stint of interactivity we had with the last example was quite good, because it identified that you didn't understand anything despite thinking you did while listening, and then you fixed it and then understood it and proved that you understood it. Okay? I'm looking for more of that, okay, and less of just the false understanding. And the faster we do this, I think the further we can go. So if it's gonna take time, let that time be like proper time, not just wasted time and hesitation. Okay. So we just said what it was constant function at B and A. What does constant function mean? Yeah, where all the terms are the same. But see, like the way you express that doesn't make sense, right? Because what terms, okay? And the same I think does make sense. So now I'm looking for like a definition, okay? See, there's no point using the word terms, right? Because we already have words to express. Yeah, I mean, saying an example but the thing is, I already know what you mean, okay? So the example is not helpful. I want you to say what you mean, though. Come on, guys, this is too delayed. I don't understand. There's like 7 of you. So something I expect would be like if all the outputs are the same, you know? Okay, and then I would like it to be upgraded to like a proper definition where if there is some y in y such that f of x equals y for all x in x. Okay, does that make sense? So there's one output and every x gets sent to that output. Okay, there's one y which every x is assigned to that y. Okay. And I mean, this should highlight that you got to be more careful with the logic, okay? Because see, like the difference between a constant function and a function is really just the order in which you wrote the x and y, right? See, the definition of a function, see, if for every x you have a f of x equals some y, yeah? Whereas here, there's some y for which every x, f of x equals that y. So you just change the order around. It makes a big difference, you know? Okay. Okay, so if you look at the words listed there, so let me think of a property, okay? So I think of a property of a function. So okay, so the idea of a constant function showed you it was possible for lots of things to get assigned to the same output, right? But what if everything was not assigned to the same output? What if everything was assigned to a different output to all the other outputs? So what if every input had its own output that no other input had? Which one of these words in the list would you think means that? Hmm? So injective one-to-one, surjective onto invertible, involution, identity, zero, constant, linear, idempotent, even, odd, periodic, bounded, increasing, continuous, additive, multiplicative. Hmm? Hmm. Do you understand the question? Where are you all? Okay, so uh, no, I need some kind of indication you're thinking about this. So out of the words listed, which one do you think means what I just said? Do you understand what I just said? Hmm. Okay, so that's 1-to-1, okay? 1-to-1. Hmm. Okay, that's very, very annoying. We say F is injective. Why are you just doodling on the screen? I'm tempted to ask if one is tarded. What is going on? I'm asking you for which word is the thing that corresponds to that property, and then we're getting weird scribbles on the screen. So change the definition of a function into that of a... So we say f is one-to-one or injective if whenever f of a equals f of b, then a equals b, okay? Yeah, so if two things have the same output, they must have been the same input. That's what that's saying, okay? And if you reverse it, notice the converse of this is saying that a function is well defined, okay? Okay, so what does that even mean? So often when we are given a definition of a function, of an actual function, well defined, okay? I don't know, like maybe the most notable example is, like trig functions, okay? Because the definition is given in terms of the angles. It's given for the angles, but your inputs, you actually take a triangle, right? So you might get different triangles for the same angle, and that should still give you the same output. How old is your sister? Okay, so that's um right. So we got injective one-to-one. Can you guess what any of these other functions mean? Can you guess what the definition of a zero function is? What's equal to zero? What do you mean? Like you can write three words. You're not usually very precise. Why can't you just be precise once? And see, everything is zero sounds a bit better. It's still not completely clear what that means, but yeah. So if you kind of it's for all x. Yeah. So another way of writing that here, I guess, is that it's a constant function when the constant's zero, right? Mm. This is like one way to write it, f equals 0. Okay, so the whole function. Alright. Can you guess what so there's a condition where if the set of outputs actually equals y, okay, we said it doesn't have to equal y, but what if the set of outputs was y? Okay. Do you know which word that would correspond to? I guess the point of this exercise is that these words aren't just random, right? You should be able to, you can pinpoint some of these words based on the description and the definition of the words. But this is taking too long. Linear. Why linear? At least you tried. Okay, so that's onto or subjective. Okay. I think people need to come up with this exercise. It's not completely a rigorous exercise, but you can definitely. So that's when you can come up with the answer a bit faster. Subjective. Or onto. See, subjective you probably wouldn't understand, but onto. That's like the one-to-one. If for every y in y, there is some x in x such that f of x equals y. You notice you're just swapping the order of the x and y, and now it's every y instead of every x, and you have another definition. Okay. What about additive? What might you guess the definition of additive and multiplicative are? What is the definition of increasing? Not quite. So multiplicative means it preserves multiplication. Okay. So if to y and x, y are sets equipped with addition and or multiplication, then we say that so surjective means everything in y comes from something in x. F of x plus y. So basically, additive and multiplicative means the addition can come first or after, and you get the same result. When referring to number theory, so when you talk about the whole numbers, this is sometimes known as completely multiplicative, and the word multiplicative requires x and y to be coprime. Okay. So for example, the Euler phi function is multiplicative, but not completely multiplicative. Alright, can people guess what increasing function means? Let me do an example here. So someone guess what the word increasing function means? Is it that for f of x equals y, y is greater than x? No, but I guess the greater than idea is good. Okay, a line has a better idea. When the y value increases, then the x value increases. So remember, you don't have control. Like if you're doing school and you're doing science, like the domain, the x is called the independent variable, right? Because that's the one you kind of have control over. And the y is called the dependent variable. Okay, so you don't actually have control over y. So a statement like that is kind of backwards, okay? So it's like if the value of x increases, okay, then so the value of x increases, then the value of y increases. You know? So it's an inequality symbol. Yeah. So f is increasing if um, a greater than b implies so f of a is greater than f of b. It's kind of funny. I mean, if you strip away all the reasoning and just memorize definitions, that's kind of like what other subjects are like. But for maths, it's like you never really have to try that hard to memorize these definitions because they're usually pretty natural. And um, if you do the problem long enough, it kind of becomes automatic. So f is increasing if whenever a is greater than equal to b, then f of a is greater than equal to f of b. Okay. Hmm. Okay. All right. So I'll give you an example to make you maybe think about these definitions. So consider a function. So this notation. So that's called interval notation. It's supposed to be in the syllabus, but it kind of gets omitted a lot. So I'm talking about the HSC syllabus. So that means all the numbers, including 0, from 0 to infinity. So all the numbers greater than or equal to 0. Okay. So that's the domain and the codomain. So if you consider a function there that is additive, okay, sure that f is both strictly increasing and injective. Okay. Hopefully that will not take more than 7 minutes. Okay, that's like a 7-minute consolidation exercise. So a function from 0, so all the non-negative numbers to the non-negative numbers, and it's additive. Show that it's also strictly increasing and injective. Do you understand the question? So for you to understand the question, you kind of need to understand the definitions of the words involved. Yeah, I'm hoping you think about this for the full 7 minutes. I don't want to wait like 6 minutes and you ask a question like, what does injective mean or something? So the question is, if you assume a function with domain and codomain, the non-negative real numbers, is additive. Okay. The question is to show or to prove that f is also injective. Okay. And to prove it's strictly increasing. Yeah, you might not know what strictly. Yeah, I mean, if this is too hard, you could try to think of like why strictly increasing implies it's injective. But either way, you have only 2 minutes. The point of this is just to play around with the definitions you just learned. Alright, do people have any ideas? You want to voice some comments, anything? It's very hard to get stuff out of you. Though I'm glad at least almost all of you have said something so far. Maybe Rihanna can do this problem. Anyone? Ooh, we have a response. Because the f of x has to increase as x gets higher, so like it cannot be the same or decrease, which means there's a one-to-one thingy. I don't know, can't explain good English, much bad. What? It was going well until the it was mainly a loss of confidence. It wasn't a loss of quality. Yeah. Okay. So what Rihanna is basically saying is that if the values of x are going up, makes the values of the output go up, then the outputs cannot repeat, right? So it must be one-to-one. So Okay, what about the other part? Do you know the other part? That additive implies strictly increasing. We first show that strictly increasing functions are injective. Suppose f of a equals f of b. Okay. And if a is not equal to b, then either a is less than b or a is greater than b. Okay, so if it's increasing, it doesn't repeat the value. If it's strictly increasing, it doesn't repeat the value, so it can't be more than 1 to 1. Okay. Okay. Now we show that additive functions on the non-negative reals are strictly increasing. Okay, so these are all definition chases. Okay, so if you look at the definition, so suppose A is greater than B, then A equals, and B equals A plus something, right? A plus something. So if B is bigger than A, B equals A plus something, right? And we want that because of additivity. We want to express things in terms of addition. Why is additivity spelled wrong? F of A plus S equals F of A plus F of S. Okay. This is actually F of A plus S is actually F of B, right? Since F of S rule, that's a little bit problematic. How do we show F of x greater than 0? We get F of B is greater than F of A. So this shows it's increasing. I'm gonna show f of s is greater than 0 if s is greater than 0. Okay, so why can't f of s be 0? Okay, can you see why f of 0 equals 0? We get from additivity. So if you put everything as 0, f of 0 equals f of 0 plus 0 equals f of 0 plus f of 0. Which implies f of 0 equals 0. Okay, so f of 0 equals 0. What if f of s equals 0? I guess it's possible, yeah. So the statement is not actually true. Because the function could just be the 0 function, yeah. So that f is either or it is the 0 function. So it actually could just be the 0 function. Strictly, so if something non-zero goes to 0, and everything before that has to go to 0 as well. Everything after that should be at least 0. Yeah. So if f of s goes to 0, okay, then everything before s should also go to 0. Yeah. Then f of x equals 0 for x less than s. Okay. Can you see that why? So if s goes to 0, then everything less than s has to also go to 0 because 0 is the smallest thing and it's an increasing function. So everything less than or equal to 0 everything less than or equal to s has to go something less than or equal to 0. Okay. But because s is non-zero, every number can be built up with copies of numbers less than or equal to s, right? Maybe this is e. Now for every x greater than 0, there is e less than or equal to s such that x equals ne the sum. Then you basically get f of ne equals f of n f of e equals 0. Okay, so that concludes the proof. If it sends something non-zero to 0, it sends everything to 0. Okay. Surely you have a question about that. Hmm. Some kind of interactive question, dialogue, discussion. What the? You can't have just gone to the bathroom in the middle of a sentence. Okay, so is everyone clear with how strictly increasing implies injective? So basically what Rihanna said. Are you okay with that? Okay. So now we're trying to show that if a function is defined on the additive, on the non-negative real numbers, and it's additive, then it's also either strictly increasing or it's the zero function. Okay, so if you look at this, how do we show it's strictly increasing? So we just look at the definition of strictly increasing, okay? So whenever a is greater than b, we want f of a to be greater than f of b, okay? So to use additivity, we convert this into an addition. So b is a plus something. That's what it means for b to be bigger than a, okay? So we get f of b equals f of a plus something, and equals f of a plus f of s, okay? So if f of b equals f of a plus something, then f of a is bigger than f of b is bigger than f of a. Okay. Now, but we want f of b to be not equal to f of a, so we need that something to be non-zero. Yeah. Okay. So then what we show is we show that f of that something is either it's non-zero, which is what we want, okay, or it's zero. But if it is zero, then f is the zero function, okay, which is also what we want. Okay, so how do we do that? Well, so if f of s is 0, okay, and s is not 0, then because it's increasing, then and f of 0 is equal to 0. Do we even need to know f of 0 equals 0? Yeah, okay. I guess if we know f of 0 goes to 0 and f of s goes to 0, then we know everything in between also goes to 0. Okay. So basically you have like a small interval that goes to 0, but every number can be made up as adding up that small something in that small interval over and over again. Okay? Does that make sense? So for example, we have that like the interval from 0 to like half. Okay. We have everything here gets sent to 0 by f. Okay. Alright, but I want to know what happens to like pi. Okay. Does pi go to 0? Well, we can write pi as sort of like a bunch of numbers in that interval added together. Yeah. So maybe it's like half plus half plus half plus half plus half plus half plus like um you know pi minus 3, right? Okay. And because we know that everything in that interval goes to 0 and pi is the sum of these things and that it's additive, then pi has to go to 0. Or pi has to go to wherever the sum of these things go. Wherever they go summed up, you know? And that's 0. So you can do that for any number, so everything goes to 0. That makes sense. Yeah, see, I do hope you understood that, but can you see like your position as a question asker is weakened by the initial premise of your question, right? If your question originated because you had to go to the bathroom, then you'll feel less comfortable asking a follow-up question, even though um you might have a really good follow-up question. Do you have any more questions about that? I feel like this is about the most I can say to you before your brain dies, so we can do the we can look at the problem a little bit. Do you understand? And still not everyone's voted. Hmm. Ooh. Yes, unclear. I'm pretty sure the person who voted unclear is Min, and that Min person that is not asking questions. Okay. Alright, everyone votes. Hmm. Yes, I have two Mins, so one of them, I just have to be right for one of them. Though I feel like this Min would vote neutral if he was actually unclear. The Nathan would vote decent. And the Slava would vote decent even if it was unclear, right? I'm just speculating now. Ooh, neutral. So that polarizes it. Yeah, of course, Nathan voted decent. Alon voted decent. Rihanna voted decent. Though I think Rihanna should vote for higher than decent, but yeah, maybe the game now is just to guess what everyone voted. Decent is the highest. Well, there's very good and perfect. And I do feel like some people who vote unclear, it's not like I would like them to vote extreme struggle, but I would like people to struggle with something extremely when it's unclear. You know what I mean? Not just kind of, just not kind of just like let it get by you. You know, like go down with the fight. You know, don't go down without a fight. Okay. Well, then maybe Priyanka feels bad about voting anything other than decent because of the bathroom excuse. I don't know. Hmm. These endless speculations. Hmm. Then you must have voted unclear, despite asking a question and not having a follow-up question. Oh, that is super bad form. Hmm. That makes sense, doesn't it? But then there are people voting decent who are not really interacting, which is very strange. Hmm. Okay. Well, you guys gotta get your act together. Okay. This is not gonna learn itself. Let's have a look at the prep problem. I wonder if you're prepared to do the prep problem. Determine all real functions defined on the real numbers such that for all real numbers x and y, that's true. Okay, so for some reason they've decided to avoid this. If you actually look at A5, this is the function notation. You know? Mhm. Yeah, so on the real numbers. So this is really f of reals to reals. So a functional equation, so usually you have an equation like x and you're solving for x and x is a number, right? So this is now you have a functional equation which is an equation in f and you're trying to solve for f, the function. Okay? And and a lot of people will be like, okay, well, blah blah blah, I can't do anything, blah blah blah, I can't solve this. So therefore everything you told me must be useless. And what I say to that is it's not that everything I said is useless, it's that you've forgotten the other things that I've said which are not specific to functions, okay? And the kind of things I say about algebra, you got to actually try numbers, okay? And if you're not doing that, I think you have very little hope. And Okay, so basically you have, instead of one equation, you have like, infinitely many equations, right? But, you know, that's kind of what a function is, yeah? Like a function is defined by all the f of x's. So it's kind of like you get one equation for every variable, except because they're so infinite, it's even if you have two equations per variable, it's still kind of the same in the end. So we want to deduce things about f. So fundamentally, you're allowed to substitute numbers for x and y, and you're allowed to substitute functions for f to just test if that function works. Okay. And what you want to have at the end is you want to have all the functions that work tested, and then to prove that there's no other functions which satisfy this condition. Okay. Okay, so there's one obvious function that works. It's called the identity function. Have you guys heard of the identity function? It's a function that just takes the input and gives it back out as the output. It's the most straightforward definition for a function. So maybe I'll define it here. We say f identity function if x equals y and f of x equals x for so literally the function doesn't do anything, it just takes the input and outputs it back. Okay. So you can see that the identity function is one of the solutions to this equation. Because if you have the identity function, f of y is just equal to y. And f of x squared plus 2 minus y f of y is just equal to what that is. So it's just x squared plus 2 minus y f of y. And that is equal to x squared plus 2 minus y f of y. Okay. So the identity function is a solution to this equation. And the question is, are there any more? Okay, so that was an example of subbing in an f. Okay. Well, maybe you can sub in x's and y's. So you can sub in x equals 0, y equals 0. You get f of 2 equals 2. No? Mm-hmm. So you know one value of the function. So if you know all values of the function, you know what the function is. Okay, and then this value happens to agree with the identity. Okay. Yeah, you can get a lot of information from subbing in values. You could sub in like y equals 0, and that will die. And you get f of x squared plus 2 equals x squared plus 2. Okay. for all x. Okay, so what that means is anything of the form x squared plus 2, if you input it into f, it'll output x squared plus 2. Okay, so essentially it's the identity function on all of those numbers. And so my question to you is, what numbers can be expressed in the form x squared plus 2? Okay. What numbers can be written as x squared plus 2 for some x? What the? Wait, what just happened? You guys still hear me? Min got dropped out again. I kind of don't want to run out of time, but I obviously haven't seen this question before, so I want to maintain that authenticity if I can. But okay, so the question is, what numbers can be written as x squared plus 2? Anyone? I cannot give you more than 2 minutes for this. What numbers can be written as x squared plus 2? So if Min just reconnected, the question is, what numbers can be expressed in the form 2 plus x squared? Okay, I'm gonna write this up while I'm waiting. Where's Rihanna in all of this? I feel like this is her time to shine. Yeah, so if you set y equals 0, so what numbers can be written in the form x squared plus 2? Okay. So any positive number can be written in the form x squared. Okay. So any number two or more, you know, can be written in the form x squared plus 2. Okay. So what that means is f is the identity on any number bigger than or equal to 2. Okay. So if you look at the original equation, the equation actually just says f is the identity on all the things of this form. Okay. And we just essentially showed that all the numbers greater than or equal to 2 are of this form. Okay. So the question is, can we show that all numbers can be written of that form? Okay. But the thing is, to know about the form, you got to know a little bit about f. Okay. So the more we know about f, the more we know about f. Okay. So we know about f a little bit, we actually can know about f a lot. So if we know that f is the identity on any number greater than or equal to 2, we can use that to our advantage here. Because to get numbers less than 2, you need a minus from 2. Right? You can't get it by plussing. So you could set x equal to 0. Okay? Set x equals 0. Then you have f of 2 minus y f of y equals 2 minus y f of y. Okay? So f is the identity on anything of that form. Okay? The question is, what does that give you? Okay. So can you tell me some numbers which are less than 2 for which f is the identity? Okay. And while I wait for you, I will type. Does this make sense? What numbers can be written in the form 2 minus y f of y? Okay, so it might not be easy to figure out exactly which numbers can be written as 2 minus y f of y, okay, because we don't know exactly what f is. Okay, but we do know something about f. We know that f is the identity on the numbers which are at least 2, right? So if y is greater than or equal to 2, then we know that y times f of y is just y squared, right? Because f of y equals y. Okay. So then y squared for y is at least 2 can get you all the numbers which are at least 4, right? So 2 minus all the numbers which are at least 4 can give you all the numbers minus 2 or less, you know? Okay. So now we have it's the identity on all the numbers less than or equal to -2 and greater than or equal to 2. Okay, so what's happening in between? So what about the numbers between -2 and 2? So what about the values from -2 to 2? I'll give you 1 minute to tell me. Please, someone tell me. Maybe Rihanna could say something. Alarmed. Alright, so basically we got all the things bigger than or equal to 2 by setting y equals 0. We got the things less than or equal to -2 by setting the x equals 0. But the thing is, you're allowed to set x and y independently of each other, right? You can literally not set them both to 0. Just set them both to non-zero, and you can get all the stuff in between. Okay. But if you're writing this down, you wouldn't actually write that. You'd probably write something a bit more precise. So what you might write is so um Now we can use a combination of x and y. So, for example, you can set y equals to 2, right? So if you set y equals to 2, you get f of, see, 2 minus y f of y is just minus 2. Yeah, so it's minus 2 plus x squared. So using the same arguments as before, this means that, okay, well, what does this mean? What numbers can be written of the form minus 2 plus x squared? So any number that's greater than or equal to minus 2 can be written as minus 2 plus x squared, right? Hence, f equals the identity is a solution is the one and only solution to this functional equation. Alright, that's it. Do you have any questions? See if this displays. How's this poll doing? Ooh, a lot more neutrals this time, huh? Just a bit of tuning out. This many neutrals and not a single question, huh? You guys proud of that? Who wants the recording? Who wants me to send them the recording? 2 decents, 5 neutrals. Alright. Okay, so I got Priyanka, Min, and Alan. Alright. Okay, if I send you the recording, you can ask me questions in the comments and maybe leave some timestamps or even some editing tips. I don't mind. Okay.